Very warm welcome, my dear students. A very good morning, good afternoon, good evening to all of you. This is the DADM, which is Data Analysis and Decision Making one lecture series under NPTEL MOOC. And as you know, this is a 12-week course for 30 hours. Total number of lectures is 60. Each week we have 5 lectures, and each lecture is for half an hour. And I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, we are in the 30th lecture, that means we are going to end the 6th week, and obviously I am sure you are doing your assignments properly, trying to understand that. Any queries based on the assignment, please send them on the forum, we will try to answer it as soon as possible. And please read the books if possible. They are definitely in depth, but generally go through the books, try to get some data sets in different fields, as I said, and the net is full of data sets, trust me. Play with them, try to plot the distribution, try to plot the cumulative distribution function, try to plot the mean, how the mean looks, median looks, mode looks, do some take some data, do some hypothesis testing, interval estimation, point estimation. Try to plot the different distributions for the discrete case, then the continuous case, for the F distribution, T distribution, chi-square, all these things. So, what I am telling is basically, if you remember on the last 2 lectures, in the 29th also I gave a brief preview that where we are heading, what we have covered, and if you remember in the 30th lecture I did say, I will just try to basically take a stock of the situation, get your feedback, understand how things are going. So, it will be much easier for me and definitely for my TAs to understand the course deliverance from your point of view and how it can be fine tuned and made much better. So, initially part we did discuss about probability, and then we did discuss about the simple data interpretation, trying to draw using the pie chart, histogram, spatial diagrams, then how you can basically draw the stack diagrams and all these things for different data sets. Then how to find out the cumulative distribution function, the PDF, the PMF, what is the mean, what is the mode, what is the median, and what are the significance of them. Then we went into trying to basically find out what is the expected value, variance. I did not give the formula for kurtosis and skewness because they are the higher moments, but definitely I did give the skewness kurtosis concept, and I will come back to that later also in the multivariate case. So, then we discussed about probability in general sense, what is the axiomatic axioms of probability, then what is the relative frequency concept, and what is the general definition of probability and difference between axiomatic probability definition, what are the probabilities of properties of probability. We dealt that also. Then we went into different type of discrete distributions, the uniform discrete, the Poisson distribution, the hypergeometric, we later on consider the geometric distribution, negative binomial, and I gave how the distributions look like, what is the PDF of that. Obviously, I did not go to CDF because you can just simply find them. Then I gave few very simple examples for each, and we also discussed the relationship of many of the cases, the binomial, then hypergeometric and all these things. As sample size increases, then we went into the continuous distribution. In the continuous distribution case, I mentioned about the exponential distribution, normal distribution, and I also discussed about the log normal distribution, and I have spent a lot of time on normal distribution, I understand, I remember. Then we discussed what is the concept of Bayes theorem, conditional probability, why conditional probability is required and on a simple problems were discussed. So, as I am saying that for each of the concept we went through small problems. Then we went into the areas of what is a population, what is a sample, different type of sampling techniques, the sequential sampling concept, the judgmental sampling concept, cluster sampling concept, and all these things. Then we came into the three main distributions, the three being F distribution, chi-square distribution, and T distribution. We discussed how the distributions look like, what is the concept of degrees of freedom, what is the PDF of the distribution, what is the expected value of the distribution, what is the variance of the distribution. I gave only the end result, did not go through the derivations of the proofs, because that is not required as such. This is not a hardcore theoretical statistic course. Then we went into discussing the concept of point estimation, the concept of we also discussed two of the inequalities, Markov inequality and Chebyshev inequality. Then for the point distribution, I did discuss what is unbiasedness, what is consistency, what are the significances of them. Then for point distribution, for different distribution as such, we all, and also for hypothesis testing. Before that, we came up with the different rules. The rules means that what is the best estimate for the population mean given the what is given the sample is there, and population mean is not known. Both in the case when the standard deviation for the population is known, standard deviation population is not known. Then we went to find out that what is the best estimate for the sample variance or standard error square for a sample given the population mean known and population mean not known. We also understood how we lose 1 degrees of freedom. Then we consider the different rules, 4 different rules based on which we can proceed and formulate the different type of F, chi and T distribution for the sample distribution case. Then we consider the point distribution, simple examples, how the sample means can be taken as the best estimate for the population mean for the, say for example, for the normal distribution, Poisson distribution, exponential distribution. Then we went into interval estimation, discussed about lower control limit, upper control limit, what is the concept of level of significance, level of confidence, that whole area being 1 minus alpha and the left and right portion of that band which is between lower and upper control limit, both the left and right of that portion, the total area would be alpha, because the total area under the PDF or the PMF should definitely be 1. Then we also considered that given the main fact that we want to find out something to do with the mean for the population, we understood in details that how we could use the Z distribution or the T distribution. In the Z distribution, there is no degrees of freedom concept. In the T distribution, there is a degrees of freedom concept, because we lose 1 degrees of freedom n minus 1 if it is only to do with one population. Then for the trying to find out the ratios of the standard deviation or the variance square for the population, we took the concept that you can use the chi-square distribution with n minus 1 degrees of freedom, chi-square distribution with only n degrees of freedom. So, the second case with n degrees of freedom being true when the population mean is known, as you know, and we use S dash square if you remember. Then the chi-square with n minus 1 degrees of freedom would be used for the case when it is S without the dash square, because you are losing 1 degrees of freedom. Then we went into trying to understand that how the F distribution could be used in the case when we are trying to compare two different variances from two different populations, and that can have F distribution with m comma n degrees of freedom, provided but the population mean from both the populations are known. And in the case the population means from both the distributions are unknown, we will use the F distribution with m minus 1 and n minus 1 degrees of freedom. Then in the case when you want to find out the difference of the means, provided the sample variances are known or not known, then we will basically be utilizing the Z distribution or the T distribution. In Z distribution again we know that there is no loss of degrees of freedom, but in the T distribution when we are comparing the differences between two means of two populations, the degrees of freedom lost would be n plus m minus 2, n being the sample size for the first population from the first population and m being the sample size from the second population. So, the total degrees of freedom lost would be 1 in each. Then later on we went into the hypothesis testing. For the hypothesis testing we use the same concept as being used in the interval estimation, but in the hypothesis testing we have 3 different outcomes of the rules based on the estimation problem. One would be in the case that when we had the less than type, greater than type, that is the second one, and not equal to is the third one. But obviously before that we understood what is the level of significance, what is the type 1 error, type 2 error, alpha, beta given H naught and H A, H naught being the null hypothesis, H A being the alternative hypothesis. So, they were errors, and I explained that with a simple example, like you being a banker, you are trying to give a loan to people with certain scores, and how it can be differentiated that alpha and betas are the errors. Then in following the same policy, trying to find out something to do with the sample mean, we use the Z distribution of the less than type, greater than type, not equal to. Then we use trying to find out something to the mean or the difference of the mean, we use either the Z distribution or the T distribution with degrees of freedom being n minus 1 if there is only one population, and n plus m minus 2 if there are two population, again of the less than type, greater than type, not equal to. Then for when we went into the variances, we consider the ratios of the variances provided the population mean were known or not known. If they are known, then obviously use the chi-square with n degrees of freedom, again less than type, greater than type, not equal to. Then for the case when you want to find out something to do with the standard deviation of the variance of one population given the population mean unknown, then again we use the chi-square with n minus 1 degrees of freedom, that means we are losing 1 degrees of freedom of the less than type, greater than type, and not equal to. Then when we came to the F distribution, when we are trying to find out the ratios of the variances of two different populations given the population mean in both the cases being known, we use the F distribution with n comma n, and for the less than type, greater than type, and not equal to. When we went to in the case of trying to find out something to do with the variances, ratios of the variances provided the population means are not known, then we use the F distribution again with n minus 1 and m minus 1 being the degrees of freedom, again for the less than type, greater than type, not equal to. Now, in all this case for the Z, for the T, for the chi, for the F, I mentioned the degrees of freedom, but I did not mention anything. I did mention again before that, but I did not mention for the time being that what would be that value of 1 minus alpha alpha. So, if you remember, if it is a less than type or greater than type, we will use the value of 1 minus alpha or alpha accordingly, and if it is of not equal to, then it will basically be 1 minus alpha by 2 and alpha by 2 corresponding to the fact that we are trying to equally divide the area on the left hand side or right hand side in equal proportions such that the total area adds up to 1. So, how does it add up to 1? Alpha by 2 plus 1 minus alpha plus alpha by 2, the total area should be 1. Then later on after this hypothesis testing, we went to the multiple linear forecasting methods. In the forecasting methods, we considered that given different type of values of y, we use the weighted method, simple moving average method, and weights were given to the past data. Then we use the exponential smoothing, where the weights are given both for the predicted data and the actual data for 1 period, 2 period, 3 period, depending on how we want to basically be accurate. But we always remembered that the sum of the weights is equal to 1, and basically we are trying to minimize the sum of the squares of the errors. Hence, we will try to partially differentiate the parameters with respect to the partially differentiate the sum of the square of the errors with respect to the parameters, put them to 0, and basically solve them to find out the alpha hats or beta hats, whatever is required. Then we went into trying to consider the trend effect. So, there was a trend, the seasonality can also be considered. So, we considered all these things, but with the main focus being that the parameters should be such that they are able to minimize the sum of the square of the errors 0.1, and then the fact was that the sum of the parameters should be 1. Then in the multiple linear regression concept, okay, by the way, we did not consider inherently any distribution for the forecasting case. Then we went into the case of multiple linear regression. So, the simple linear regression we considered only one x independent variable and one dependent variable. We consider alpha as the point where the line, the average line being y is equal to mx plus c, the example which I kept giving time and again. So, that where it cuts the y axis, that was the value of alpha, and beta was basically the rate of change of the value of y with respect to x as x changes by 1 unit. Then we assumed, obviously there is an error would have a particular distribution which was a mean value of 0 and a variance of 1 or sigma square, and the distribution was normal in case. And then in the later, I will come to the assumptions in totality. Then we went to the multiple linear regression. We considered that there are more than one x, that is x 1, x 2, x 3 till x k suffix k or x suffix p, and obviously there is a alpha or a beta naught depending on how the problem has been formulated, and obviously there would be an error epsilon, and utilizing all these things we will try to basically predict for y, which is the dependent variable. Then obviously we had few assumptions. The assumptions were that the rank of the matrix was k or p of the x matrix, and what is that? We remember that all of them should be independent of each other, and none of the rows, none of the columns should be expressed as linear combination of the rest. We considered the covariances between the error themselves from time period 1, 2, 3, 4 would be 0, that they are independent. The covariances between x's and epsilon or the errors would be 0 also, that means the errors do not affect the x's, and obviously as it means the rank of the x matrix is k, that means they are independent, hence the covariances existing between all the x's between themselves is also 0. So, based on that we found out what is the mean value of y, we found out what is the variance of y, and then the main focus was basically to minimize the sum of the squares of the errors, differentiate with respect to alpha and beta, put it to 0, and then find out the values of the estimate of alpha and beta. So, those are denoted by alpha hat, beta hat, whatever it is, but this partial differentiation rather than differentiation, partial differentiation was important because we want to basically find out the rate of change of these functions, keeping the change of y with respect to any one x, considering the rest of the x values are not changing, they are fixed. And then in the last two class, in the 29th class and the 20th class, we spent a lot of time in trying to understand what is the QQ plots, how normality could be understood, and how the one to one correspondence between the CDF of a normal distribution and CDF of a unknown distribution can be mapped in order to basically find out the quantile plots. And then in the fag end of the 29th lecture, I started basically giving 3 different examples of a dietitian, of a person who is of a real estate agent who wants to basically find out the price of the house, and third being a faculty who wants to find out how does the prices of different stock move, are they moving in tandem considering they are from the same sector or all these things. We consider these 3 examples, and I told you also in all these 3 examples the main focus was to basically find out some relationship or find out some distribution based on the fact that there are more than one number of random variables, and they are basically x 1 to x p or x k suffix x k or a suffix x p, which would give us a whole lot of information related to the PDF of some distribution, related to multiple linear regression, related to say for example, other methods of ANOVA, MANOVA, factor analysis, cluster analysis, conjoint analysis, structural equation modeling, all this will be coming. And here now I will basically say the overall jump of the quantum concept of in the multivariate case starting from today, which is the 30th lecture, would be a little bit different. So, I would rather maybe in many of the cases I would try to go slow, a bit slow, and even if I am fast, please bear with me. We will try to basically cover the basic concepts, which will give a lot of information for the students who are taking this course in order to basically build up their concepts after somebody goes through this DADM 1 course. Obviously, I am not saying this is the best set of topics we I am going to cover, I am able to give the best examples, but I am trying to basically inculcate the interest in all of you, such that you can pick up any good books and start reading it, such that it will give you a good base for the area of data analysis, decision making, multivariate analysis, multiple linear regression, structural equation modeling, conjoint analysis, factor analysis and all these things. So, with this it is basically a brief wrap up of all the 29 classes which we have covered. So, obviously, it would have been at the middle of the 30th lecture, but I thought I will just give you a brief background. So, that means once you are able to appreciate where you stand and how the teaching has been going on, you will basically feel much more comfortable than what things you are going to face and how you are going to tackle the problems accordingly. So, coming back to the multivariate statistical methods, if you remember, I did mention that in the last slide of the 29th class, that given one x, which is a matrix which has basically p number of random variables, all of them are independent of each other, and each p number of random variables have basically n number of readings. So, it will be as so capital X, which is a vector, I should write it like this, wait. So, hopefully, this is I am able to denote this as a bold. That will be equal to, so the nomenclature may change, but the general essence remains the same. So, it will be x 1 1 till 1 x 1 n, and this will be x k 1 x k n. So, there are basically, if you consider the number of rows and number of columns, it will be of the size k cross n. So, k, or in many of the examples later on you will see p. So, k is basically the number of independent variables, n is number of reading, and this in many of the problems this will be given as p also. So, whether you use p or whether you use k would hardly make any change in the understanding. So, given this matrix X, we want to basically predict or find out from PDF or PMF of the actual set of observations, because there are different random variables which affect the reading and we want to find out the relationship. So, it is interesting to note that Francis Galton may be credited as the first person who worked in the area of multivariate statistical analysis. In his work Natural Inheritance, which was published by Macmillan and Company, the author basically summarized the ideas of regression considering bivariate normal distribution, and he considered the children born to parents, and depending on their heights, basically the bivariate normal distribution was basically plotted or given an idea, such that one could understand that given two variables which are normal, how you can basically find out the interrelationship between them, which is a bivariate normal distribution. So, to start with, again I will rehash. So, let us consider this matrix X. So, all these are bold, remember X is a bold, is a matrix, while these x 1 till x p are basically the vectors. So, they would also be bold. So, let us define x which is of size n cross p, which consists of p number of random variables. So, each element will be denoted by x I j, I is basically from 1 to n, j is equal to 1 to p. So, p is the number of random variables, n is the number of readings. So, here x I j, I is equal to 1 to n, j is equal to 1 to p is basically the n cross p dimension matrix of random variables, where n signifies the number of readings, while p basically signifies the dimension. So, and it corresponds to different factors in a random variable, which are of interest to us, based on which we will try to basically do our studies. So, we will basically have some nomenclature and definitions. So, definitions will be coming time and again, and we will try to basically give an example of the problems rather than going to the detailed solving of them, because they consist of lot of theorems which I do not want to go and proofs. Obviously, there were proofs in the univariate case also, but we skipped that, and here also we will skip that, but the initial phase would be more of the discussions of the distributions of the concepts with solved examples and the results analysis. So, the mean value of this multivariate distribution for each one x 1 to x p, there would be mean value given by mu 1 to mu p. So, we will basically denote mu 1 to mu p collectively as a vector of mu size p cross 1, where the first element is the mean value of the first random variable x 1, second mean value is basically the second and the first actually the mean of the second random variable, and so on and so forth. While when we consider the sample counterpart, the sample counterpart would basically have the sample means. The sample means would be given by x 1 bar for the first one, x 2 bar for the second one, till the last one, which is x n bar for the x p bar, sorry, my mistake, not x n bar, x p bar for the pth variable. Now, the variance covariance matrix technically would be given by matrix of size p cross p, and the p cross p would basically have elements along the principal diagonal. It will be the covariance of the first, I am talking about the elements. So, 1 comma 1, then 2 comma 2, 3 comma 3 till p comma p, which is the principal diagonal. The first element in the principal diagonal would be the covariance of the first with itself, which is basically the variance of the first. The second element, which basically would be 2 cross 2 comma 2, would be the covariance of the second with itself, which is the variance of the second, till the last one would be, which will be the covariance of the pth one with itself, and that would basically be the variance of the pth one, and the off the diagonal element would be all mirror image. So, the I j element would be exactly equal to the j I element, where I j element would be the covariances of the ith and the jth one random variable. Similarly, the g I element would be the same and the values would be exactly the same. So, they are just mirror images. While when we consider the sample counterpart, we will basically take this the square of the standard errors, and we will use the same formula, whether using s dash, s would basically depend on whether the mean value is known, not known. So, again it will be a p cross p matrix. Principal diagonal would exactly be the standard error squares. The first element would be basically S 1 1, which is the standard error square, or the covariances between the first to first, which is basically the variance standard error square, or the sample variance of the first. Similarly, the 2 comma 2 would be the sample variance of the second, and the last element would be the sample variance for the pth one. And again the of the diagonal element would be mirror image of each other. They would basically be the covariances for the sample 1 and sample 2, and similarly the mirror image would be the covariance of the sample 2 to sample 1. So, similarly, if you find out the covariance of the ith and jth, it will be exactly equal to the covariance of the jth and the ith from the sample counterpart, and that these matrices for the case for the sample would be denoted by capital S, which is bold, and obviously it will be size p cross p. So, with this I will close this 30th lecture and continue more discussion about the results or the definitions, nomenclature for the multivariate case in a much better way, such that you appreciate as we proceed with the discussion of multivariate statistical analysis. Have a nice day and thank you very much.